Adding, subtracting, and multiplying radical expressions. How to add and subtract? You gotta simplify radicals first. And then you basically combine like terms. What like terms are, or like radicals, they got the same radicand and the same indices, or the same index. Here we go. Just give you an example. When you see the examples, you'll see how this is done. This isn't that bad, so don't make it bad. When you look at a part, you'll notice that all of these have the exact same radical, same square root, same radicand. They all have square root of 6. It's as if they all have an x. See it the same way. You gotta add and subtract the numbers in front, the coefficients. 2 plus 4 minus 8. 2 plus 4 is 6. 6 minus 8 is negative 2, so you get negative 2 square root of 6. Same thing as if it were 2x plus 4x minus 8x. The exact same thing. B part. Notice they both have 4th root of x. So we're going to keep that 4th root of x as it is. We're going to combine the numbers in front. Negative 3 minus 2 is negative 5. We're done. Now notice C part. 2 of these have square root of 7x. The other one has a cube root of x. So the 4 square root of 7x minus square root of 7x are like terms. So we're going to combine those. So we're going to keep the square root of 7x as it is. Now if you need to, that minus square root of 7x, that's the same as minus 1 square root of 7x. And 4 minus 1 is 3. Now the plus 2 cube root of x, you just bring that down, because it's not a like term. We're done. That's your final answer. D part's where you really got to start paying attention. Looks like you can't combine them. Maybe you can, maybe you can't. But all I know is that we got to simplify first. And both of these will simplify. So, let's simplify the square root of 32 first. Now the biggest perfect square factor of 32 is 16. Now 4 is also, but 16 is the biggest. So if you're at 32 is 16 times 2. I'm going to do these one at a time. Now the square root of 16 comes out of the 4 and the 2 stays. Now here's a little heads up on how to simplify these. Normally what one of them ends up being, in this case square root of 2, that probably means that that 2 will also divide into 8, and the other factor usually is a perfect square. So in this case 2 times 4 is 8. 4 is perfect square. So we're going to rewrite square root of 8 as square root of 4 times 2. Square root of 4, that 4 comes out as a 2, and that 2 stays underneath. Now we have like terms, because both have a square root of 2. And 4 plus 2 is 6. Simplify first. Now let's simplify E part. Negative square root of 75. First off, we're going to keep that negative sign on the outside. 75 isn't perfect square, but it does have a factor that is, which is 25. So 75 is the same as 25 times 3. Get the negative sign. The square root of 25 comes out as a 5, and 3 stays underneath. Now, keep in mind that we have a 3 underneath, which means that the 3 should divide into 108, and what results is a perfect square number. Let's see if that's the case. So I'm going to bring down the plus 4 and see how many times 3 goes 108. It actually goes 36 times, which is always good because the square root of 36 comes out as a 6. The 3 stays. Now keep in mind this 4 and 6 are multiplied together. It's 4 times 6. So we end up with negative 5 square root of 3 plus 24 square root of 3. And then we combine our like terms like we always do, as if they were x's. Negative 5 plus 24 is 19 square root of 3. Now let's do E part. It has a few variables. They got different indices. And that still happens when we simplify first. Here we go. Field through 32, that happens to be 2. 5 doesn't go into 7 evenly, so that means that we're going to have to divide it out. So 5 goes into 7 twice, or once, 5 goes into 7, one time. So that means we have x the first on the outside, and we got an x underneath the field through. Make sure you get that field through in there. And so 5 goes in 7 once, and leaves the remainder of 2, so that goes on the x on the inside. Plus 8x fifth root of x squared. Notice that they both now have fifth root of x squared, and they both have an x term in front, so this is definitely a multiple combined like terms problem in the sense that they both have fifth root of x squares, and both the coefficients have x's, so 2x plus 8x is 10x. Final answer is 10x times the fifth root of x squared. That's a fun one. Now, let's go to multiplying radical expressions. Now what this is basically the distributive property, or the full method, depending on how it's set up. We're going to multiply coefficients, and we're going to multiply radicands, simplify whenever we can, combine like terms whenever we can. We're going to assume all variables are positive real numbers, so we don't have to worry about absolute values. So here we go. Let's do A part. When you look at this, you'll see negative 3 square root of 5 times 4 square root of 5. This is nothing but one big multiplication problem. Negative 3 times the square root of 5 times 4 times the square root of 5. We're going to go ahead and multiply square root of 3, or negative 3 times 4. I may have said square root of 3, but I meant negative 3 times 4, which is negative 12. So I've done these two. But now I have the square root of 5 times the square root of 5. The square root of 5 times the square root of 5 is the square root of 25. But lo and behold, the square root of 25 is the same as 5. And the square root of 12 times 5 is, I said square root of 12, I should be saying negative 12. I got square root in my mind. Square root on my mind. So it's negative 12 times 5, which is negative 60. Final answer is negative 60. Now let's do B part. I'm going to write it all out. By the distributive property, we get 6 square root of 7 times the square root of 3 plus 6 square root of 7 times 8 square root of 11. And then watch this. 6 times the number in front, which happens to be a 1, is just a 6. Square root of 7 times the square root of 3 is the same as square root of 7 times 3, which is 6 square root of 21. That doesn't simplify, so I'm not going to. Now for 6 square root of 7 times 8 square root of 11, I'm going to multiply the numbers on the outside. 6 times 8 is 48, so I'm going to write it all out. So it'll be 6 times 8 on the outside, and then square root of 7 times 11. The 7 times 11 under the square root. So you have 6 times 8 is 48, and the square root of 7 times 11 is square root of 77. That doesn't simplify. The reason why I know it doesn't simplify, it doesn't have a perfect square factor, neither does 21. So that's our final answer. Now, I easily could have bypassed a lot of these steps. I could actually do it in one step by taking right down to 6 and then taking square root of 7 times square root of 3 is square root of 21. Then taking 6 times 8 is 48, and square root of 7 times square root of 11 is square root of 77. Easily done in one step. If that's what you want to do, fine by me. In fact, that's the way I'm going to approach the next problems, which involve the full method. Full method says I'm going to take the square root of 2 times the square root of 3, and I get the square root of 6. Square root of 2 times the negative square root of 5, I get negative square root of 10. Plus 9 times the square root of 3 is 9 square root of 3. Minus 9 times the square root of 5, which is 9 square root of 5. Nothing simplifies, nothing combines together. I'm done. Sometimes that happens. That's what you're hoping for. Now let's do this next example. Full method once again. Notice each binomial is the same except for the middle sign. Let's see what happens in this case. Square root of 4x times the square root of 4x is the square root of 16x squared. And then we got square root of 4x times negative 7, which is negative 7 square root of 4x. Now you easily could have simplified first, but that's okay. Let's just go ahead and do it like this. Plus 7 times the square root of 4x, which is plus 7 square root of 4x. And then 7 times negative 7 is negative 49. Now watch what happens. These two middle terms, negative 7 square root of 4x plus 7 square root of 4x, are like terms. And then negative 7 plus 7 is 0, so they're gone. This square root of 16 is the same as 4. The square root of x squared is x. And then the only thing left is a minus 49. No square roots remain. That's what happens when you multiply two binomials, and the only way they differ is by the middle sign. You're going to find out something special in the next video. That's what we're doing now. Full method. Now let's do this last example. This one's missed by many people. I think there's a shortcut, and there is if you know what it is, but it's easier to just do it this way. To rewrite it as two different binomials. 3 minus square root of 7 times 3 minus square root of 7. That's what the exponent on the outside, the 2 on the outside parentheses means. There's two of those being multiplied. So now I'm going to do the full method. 3 times 3 is 9. 3 times negative 7 is negative 3 square root of 7. Negative square root of 7 times 3 is also negative 3 square root of 7. And the negative square root of 7 times negative square root of 7 is a positive square root of 7 times 7, which is 49. Sooner than later, you're going to figure out that square root of 7 times square root of 7 is actually going to be 7. You do enough of these, you'll see that. Let's combine like terms. 9 is by itself for now. We got minus 3 square root of 7 minus 3 square root of 7, which is minus 6 square root of 7, because those are like terms. And then plus square root of 49, which happens to be 7. And since we have a 9 plus 7, we're going to add those and get 16 minus the 6 square root of 7, and we're done. They're not bad, so don't make them bad.